And welcome to 19-4, where we're going to be dealing with neutralization reactions. In this section, we're going to try to determine an unknown concentration of either an acid or a base. And the basic idea is this. If you take a sample, say, of an acid, and you know how much acid you have, you can take a base of a known concentration, add it to that acid until it neutralizes it, and then be able to determine what the original concentration of that acid is. And you could flip that. You could determine an unknown concentration of a base. So let's go ahead and jump in here. Remember that an acid-base reaction is simply this. And let me get my pen. Here we go. And change colors. Go black here. If we're dealing with, say, hydrochloric acid and sodium hydroxide, remember what's going to happen is that the hydrogen is going to be donated. The hydroxide ion itself is going to accept it. Or if you're dealing with something like sulfuric acid, it has two hydrogens, so therefore we're going to need to have two hydroxides to accept them. Now in any case, when an acid or a base is neutralized, the hydrogen concentration will have to be equal to the hydroxide concentration. That's by definition. That's what a neutral solution is, as you learned earlier in the chapter. Or you could say that the number of moles of hydrogen will have to equal the number of moles of hydroxide. That's also a valid statement. Or if you do a calculation similar to what we did before when we're doing dilutions, you can simply take the concentration times the volume, and that is going to equal the number of moles. And you could do the same thing for the base. And in the end, you have this equation which looks similar to our dilution equation, where you have the concentration of your acid times the volume of your acid will have to equal the concentration of the base times the volume of the base added. That is an equation that you will be able to have on your list of things that you can use on the test. So therefore, you can determine unknown concentrations if you know how much of a known base is required to neutralize an unknown salt. The point at which an indicator changes colors. Now, we haven't mentioned the indicator. An indicator will change colors at various pHs, and so you have to pick your indicator wisely. But the point at which the indicator changes is going to be called the endpoint. Or in the case of a strong acid base, which is all we're going to be doing in this class, it's going to be called the equivalence point. Or sometimes it's also called the neutralization point. And here's how it works. Let's take a look at example number 1. If 20 milliliters of 0.25 molar sodium hydroxide is required to neutralize 10 milliliters of hydrochloric acid, what is the concentration of the hydrochloric acid? All right, now, the thing that we got to remember is that we're dealing with the concentration of the hydrogen and the concentration of the hydroxide. So, if we have this equation, MH plus VH plus equaling MOH VOH, simply plug in our values. The concentration of the hydrogen, we don't know what that is. The question says, what is the concentration of our acid? So, we don't know what that is. The volume of the acid is 10 milliliters. The concentration of our hydroxide, well, it's 0.25 molar and you only have one OH, so it's going to be the same concentration. So this is 0.25 molar hydroxide, and the volume of that hydroxide is 20 milliliters. And so now we can solve by dividing the 10 milliliters over to the other side. The milliliters divide out. Let me finish my parentheses there. You're left with molar. We're looking for molar, so now the hydrogen concentration is going to equal 0.25 times 20 divided by 10, and that gives me 0.50 molar hydrogen. Now, we are almost done. You have to change hydrogen into our HCl. Well, there's 1 mole of HCl for every 1 mole of hydrogen. And if you remember, this is simply moles over liters, so we can divide out the moles of hydrogen, top and bottom, and we're left with moles of HCl over liters, which is concentration still. So we have 0.50 moles per liter of HCl, or you can use capital M for molar. All right. Now you might say, well, why do we need that step if it's just the same? You're going to see later on in the notes. All right, so let's go ahead and try another practice problem. Flipping the page, example number 2. If 50 milliliters of 3 molar sodium hydroxide is required to neutralize 100 milliliters of HCl, what is the concentration of the HCl? So once again, we'll set up our relationship. MHVH plus equals MOH VOH minus. And just plug this thing in. Do we know the concentration of the HCl? No, that's what we're trying to solve for. Do you know the volume of our acid? Yep, it's 100 milliliters. Do we know the concentration of our base? Yep, 3 molar. And because there's only one hydroxide in the compound, it stays the same. Okay, so we do have 3 molar sodium hydroxide. And the volume of the base added is going to be the 50 milliliters. And so now we just need to solve for MH by dividing the 100 milliliters over to the other side. These terms divide out. The milliliter unit divides out. You're left with molar. And therefore MH plus will equal 3 times 50 divided by 100 is 1.5 molar or moles per liter of hydrogen. And once again, we're going to have to change that over to HCl. It is a 1-to-1 ratio. So 1 mole of HCl for every 1 mole of H plus. Why? Because there's only one H in every total HCl. The moles of H plus divide out. You're left with moles of HCl over liters, so it is 1.5 moles per liter of HCl, or if you wanted to write it as 1.5 molar HCl, that would be equally fine. All right. So that's how you do these types of questions, where you simply use your equation, see what you know, see what you don't know, what are you trying to solve for, and just do a simple multiplication or division problem. Okay? In the next podcast, we're going to take a look at the lab technique that we used for determining unknown concentrations, and that technique is called a titration. We'll see you next time.